Today, we have the esteemed Joel Moses, F5er, with us today, and we're excited. We're going to talk about the Open Programmable Infrastructure, OPI project. And Joel, just to get started right off the top, what is OPI?
Well, like you said, it stands for Open Programmable Infrastructure, and it's a Linux Foundation project that was initiated by a number of different parties, the founding members being Red Hat and Intel and ourselves. We were able to entice a lot of other competing entities to also tie into this project under the promise of what an emerging market for something called DPUs or IPUs, or if you want to just abstract it, it's XPU, right? These are specialized pieces of hardware that we're trying to create an open marketplace for services on top of. And that's the whole intent of the Open Programmable Infrastructure project.
Okay, so that's, I guess, shocking would be a term. We're bringing competitors together. That does not sound intuitive. Why is that? Why is that important?
Well, it requires you to go back and look at a little bit of history in the networking space. At the very beginning of all of this, we had network interface cards, and those cards fit into general purpose computers, and they did a networking task, but they did a very basic job with it. And then NICs started to get a little bit smarter until we got to the present round of what they call smart NICs. And smart NICs are an interesting beast. A lot of companies like Intel and NVIDIA, for example, they make smart NICs. But these smart NICs, they accelerate a portion of a networking task, and they tend to do so in different ways. And so we support smart NICs at F5. We work really well with them inside of our Big IP VE. However, we have noticed as the service provider for our various services that it's very difficult to get onto the train of a smart NIC and to support all the various versions and sometimes even the production runs of individual cards. There's differences in the way the software composites, there's differences in drivers, there's differences in how the hardware functions, and we have to keep up to date with all of that, and we have to custom craft things. It takes a lot of time. It takes a lot of skill, and we do that. However, smart NICs have not taken off like everybody thought that they would, and the reason for that is because of this pain that every ISV goes through when they try to integrate with a smart NIC. Now, these smart NICs are getting smarter, and they're turning into these things that are being called infrastructure processing units or data processing units, which essentially are, if you take a smart NIC and you put a little general purpose CPU on it, and you tie that general purpose CPU into the complex on the card becomes an environment unto itself. It's something where you can run code, you can run containers and various other things, and you can tie to the hardware that's on those cards. The card then becomes a place where you can host things, and more importantly, it becomes a place where you can abstract away some of the driver version differences and hardware differences. And it was the transition into this space of technology where we noticed for the first time these smart NICs turning to DPUs were getting much, much more capable than ever before. And all we really needed to do is try to convince people to do things in a common way on these types of hardware. We're very excited about DPUs, by the way, because DPUs look almost identical to how we engineer appliance platforms. I'll share a little bit about that. If you think about a DPU, think about it in terms of a transparent server that's sort of plugged into another server across a bus. So this is how these cards are designed to work. They have general purpose CPU, and that's butted up across a PCI bus to the CPU that's in the server node. And the DPU has a little bit of storage. It has a network interface. It has other accelerators that are on it. And so the card can present itself to the underlying server as a NIC. It can present itself as a disk controller. It can present itself as a serial device. There's a ton of different ways that the card can expose its resources to the underlying server. Effectively, the DPU allows you to take and create an infrastructure zone and layer on top of your general purpose compute infrastructure that is completely separate and isolated from the underlying compute. That is a really enticing thing for certain customers, especially customers like service providers or financial services companies that want to provide a base level of infrastructure support through the network, but they want to isolate the actual applications, and DPUs are looking very exciting for them. So because these cards have to run code and they have to run services, they have to have a way to inject something onto the network interface and present itself to an underlying host, they are engineered, they are designed. If you look at a block diagram of a DPU and a block diagram of a big IP hardware appliance, they look almost identical. And so this is essentially like taking a big IP and stuffing it inside of a slot. So we're very excited about it. Now, we knew, though, that we had a lot of different vendors, Intel, Marvell, NVIDIA, AMD, all producing these DPU cards. They all have either cards on the schedule or they have cards in production and shipping today. So we wanted to get ahead of that. And we wanted to create something that allowed these cards to be used and for our services to plug into these cards in a way that would work across vendor platforms. And that's what the OPI initiative is about.
So when it comes to the OPI initiative, we see the benefit of doing this in an open way and working with our competitors. Is this something that F5 would have found really hard to try to pull off on their own and make it potentially proprietary and make it a business advantage as opposed to being open about it?
Yeah, so we're obviously, by creating something that is generally usable by ISVs, we're opening the door also to our competitors to produce services for these same cards. But we think that a market for these cards raises all boats. Okay, so think about the power of having this type of hardware available inside your infrastructure, where you can offload all these infrastructure operations to the card and not impact the underlying compute for your application. It's exciting. It speaks to some long-held desires, both in enterprise and hyperscaler and service provider space, that we've heard. And so the difficult part wasn't, by the way, convincing ourselves that we might open these things up to competitors. The difficult part was getting competitors who produce these cards to realize the importance of working together to create a common infrastructure. And that is what the OPI project is about. And we're pleased to have Intel on board. We're pleased to have Marvell on board. We're pleased to have NVIDIA on board. They are good partners. We're pleased to have Pensando from AMD on board. Everybody has come to this party, and we're very happy about that.
As far as our attack angle for how we, engage with the cards themselves, are we taking an engineering mindset to providing direction on the cards, or more of, oversight and steering? Like, will we have a play in? You mentioned that big IP as a card, that would be what it is. Are we engineering cards, or are we just providing steering for that?
No, we're providing steering for that. We see a lot of great momentum within the equipment providers, within the hardware manufacturers, to produce really good quality hardware, things that run with low power budgets. Remember, these things have to fit inside of a server, so you don't want them to exhaust the power capacity of the bus that they sit on top of, right?
Yeah.
So these cards are almost universally based on the ARM processor. But they have, some of them have 64 cores of ARM available for doing work within these cards. On top of that, they have FPGA complexes, and they have crypto accelerators. They have storage acceleration capabilities. There's a ton of things to like about them. And what we're trying to do is allow the equipment providers to produce and enhance and release these cards at a rapid pace, while the OPI kit that sits on top of it will give us a stable environment in which to produce our services. So all we have to do is just sit back and watch as the vendors accelerate their hardware destinies, and our software can run and take advantage of new enhancements as they come along because of the marketplace approach.
So with the OPI kit itself, is that something that is installed at host level and then your services writing on top of that take advantage of? Or is that something that as you deploy your package, it takes advantage of that and embeds?
Yeah, so you caught me here. So the OPI project is newly initiated. We initiated it in July, and so the teams have come together and they've first completed a common taxonomy for the cards. They are working on common API sets. NVIDIA donated their Doka toolkit to the project as open source. Intel introduced as open source to the project the IPDK project. So we're assembling a lot of different constituent parts right now. In the end analysis, what we're hoping to get to is a common API set and a couple of reference architectures that can be used to produce what we're calling an OPI compliance factor for the cards. What form that's going to take, we're still working on that. And that I want to be also pretty clear about this. We need other people to come work with us. Okay, this is a fast-moving open standards project under the Linux Foundation. It has a lot of attention. There are a lot of people who are coming to the project and contributing to it. And we want not only other service providers, but we also would love our customers to get involved. One of the things that the OPI project is trying to do is collect, collate, and introduce use cases for this technology, so that when we produce designs, those designs are custom tailored for the use cases that customers bring us. We have participation from people like Comcast, for example, in this project, and we're really happy to have them.
Yeah, I remember filming a light board for the SmartNIC stuff that we introduced years ago.
Right.
And just to see the power of purpose-built compute within a general compute environment for the services that right on top of that was exciting. And to see that, the emerging markets that are coming with additional services on top of what SmartNIC provided is exciting.
Right. Absolutely. Yeah, we're very intrigued by the possibilities here. And we've had a lot of customers asking us, well, what are you going to do about these things that are coming out? So we're trying to get ahead of that in a way that's going to benefit the entire industry, not just F5, but in benefit the entire industry. We think that these cards could potentially be game changers.
You would think, in the game of cat and mouse, when it comes to cybersecurity, and let's say you have a SaaS platform that has web application security from an AI and ML perspective, and if some of that can be pushed down to an XPU, hopefully we start gaining an advantage in cybersecurity as opposed to always kind of catching up to what attackers are doing.
Yeah, absolutely. We've been doing a lot of thinking within the OPI teams about how to create a denial of service control infrastructure that allows you to assign DPUs to mute out a denial of service attack and then return DPUs back to an unused or idle posture once you're done with it. This is spare compute that you can provision, stand up, cluster, distribute across, and then shrink back down. And the cool part about that is you can handle the denial of service task right there on top of the server without affecting the underlying compute that the application runs on. The application doesn't even know that there's an attack underway. Instead, the card is aggressively handling that for you.
Yeah, there's the classic scenario in a DDoS where you have this blast radius of like everybody else in the data center going through the attack along with you. And if the attack, if you could kind of bring that protection closer to the service itself. That sounds awesome.
Yeah, we think it would be great to add that feature to an infrastructure zone of DPU equipment. And the DPU can assign itself to the task of this defense, and it can be released back once the attack abates. That's definitely one of the things we're looking at.
Yeah, that just makes me think of telemetry stuff as well. Like, if you have these, auto swarming DPUs that can handle all that stuff, who gets access to that telemetry?
Yeah,
How do you...
actually, the OPI project has already chosen a telemetry standard, and it is Open Telemetry, which is
there you go.
is what we're doing in lots of our other products as well. And yes, Open Telemetry can actually be produced from the card directly. It doesn't have to have any software on the host itself. You can actually have Open Telemetry run an eBPF filter and then channel that information out to OTel. And you can do it directly from the card without the host ever being aware that anything is going on. It's very, very powerful. I want to also note one important thing about these cards. Almost universally, with one exception, and I'll let you guess which company, these cards are based on ARM processors. And I think it's important, especially for the DevCentral community, to kind of understand the transition that's happening out there. And it's something we're watching closely. And there is a transition to ARM. Most of the public cloud providers, in fact, I believe it was 2 weeks ago, Azure released its very first availability of ARM compute in Azure Cloud. That follows, of course, GCP having ARM instances available. And naturally, Amazon is taking EC2 to ARM by doing it completely different than the rest of the other cloud environments. They went out and bought a chip company that produces these things for them, and they produce that as well. ARM has a couple of interesting characteristics. It is a RISC-based infrastructure. It's a RISC-based platform, and it is extremely power efficient. It offers a sufficient level of compute density per watt. And that is fantastic for hyperscalers, for service providers, and for cloud providers. In fact, the cloud providers are offering between 20 to 60% discount against traditional instance types to ARM instance types. And so we've talked about this before, I know. But things begin in the public cloud and they filter out from the hyperscale to the enterprise. And so we're fully expecting, and we do believe that Gartner is right, that by 2025, 25% of data center compute will likely be ARM-based. And we expect that a significant percentage of that might actually be in DPUs.
Yeah. Do you see any challenges on the just infrastructure side or security side with the transition that rapid?
Yes. The way that ARM does things is slightly different. If you're into confidential computing and things like that, the tooling on the x86 traditional side is much better. However, it does exist in ARM. It's just a little different. And so from the support perspective, just for the hardware, the customers will need to take that into account. The biggest challenge, though, is getting your software ready for ARM. Luckily, there have been enhancements in compiler tool chains that make that porting relatively easy. It used to be non-trivial to get from CISC x86 to RISC ARM. But with the advent of the newer GCC compilers and Clang, cross-compiling is fairly easy. However, it is not exactly what I would call a skill that every developer knows how to do. So as the transition occurs, it's going to happen this way. It's going to be the business leaders saying, hey, is there a way to run this workload cheaper? And the bright minds in an enterprise are going to wrap their heads around it, and they'll say, well, we could shift the instance type from x86 to ARM. And that at that point, they'll start thinking about, okay, how do we do that? And again, we've got some time for this transition. It's going to happen reasonably rapidly because of the cost pressure that the public cloud providers are placing on it. But it will happen.
I think innovation would probably drive that as well. And like you get some new SaaS company that's completely based on some sort of ARM architecture, and it blows past others because they can do it cheaper and faster.
Yeah.
It's going to push everybody out. That's the rising tide, perhaps.
Yeah. Well, I want to be very clear on the DPU side. It's using ARM because ARM has the power characteristics that are needed for an add-on to a server. Okay. It isn't necessarily that compute is cheaper. DPU cards aren't going to be cheap, at least not initially, unless somebody out there creates a marketplace for services that run on top of these cards and they become phenomenally popular and thus much cheaper. But they are a bit more of an expense. What is really beneficial about them is they provide the ability to take an application workload and wrap a service around it without ever affecting the compute of the application workload itself. The compute workload knows nothing about the services and the compute that's in front of it, that's doing its tunneling, that's doing its SSL decryption, that's doing its storage operations, knows nothing about all of that. So it creates a different zone. It creates an application zone and an infrastructure zone within your architecture. It's here where I should probably point out that we did write a book recently. I was going to have a copy of it to hold up, and then someone walked by my office and I gave it to them. So it's an O'Reilly book and digital enterprise architecture. And the DPU features prominently in there, but we talk about things like creating an infrastructure zone of operations within your architecture they're very useful. So I'd encourage, if you're interested in that, to go to f5.com. It's available as a download.
Well, Joel, thank you so much for taking the time to come share about the open programmable infrastructure. I'm excited about it. I'm excited to see where the industry goes with that. And, I'm excited that, as a Slackware, 0.5 builder and person of handling device driver nightmares for weeks at a time, I'm excited that hopefully that problem goes away for a lot of people.
That would be fantastic, wouldn't it? And if anybody wants to help, it's github.com/OPI project. That's the main repo, and you can see all of the work that we're doing inside there and all the work, the good work that our industry partners are doing as well.